This is the thing that people find shocking. It's 100% about mathematics. The first type of shuffle is a riffle shuffle. This is one of the most commonly used shuffles. You cut the deck roughly in half, then you drop cards one at a time from each pile, and then you just riffle, shuffle them like that. Rule of thumb is you need about 7 of them. One way to explain that in terms of guessing is if a deck is perfectly mixed, you can only guess about 4.5 cards correctly. If you do a riffle shuffle once, you can guess over 30 cards. If you do twice, you can guess over 19 cards, and if you do it 3 times, you can guess almost 13 cards correctly. There's also something called the overhand shuffle. You can do it on a table or in your hands. If you do it on the table, it works like this. You take off some cards, and you take off another stack and put them on top, and you keep going. The thing that's most surprising is that for the overhand shuffle, you need thousands of them. In fact, maybe close to 10 or 11,000. So that's a very poor method. The last one is called the smush shuffle. The idea is you sort of spread the cards out, you move them around, and then at the end you regather them. You need about 30 seconds to a minute to mix things up. So that's comparable with the time needed to perform 7 riffle shuffles. These results on how many times you need to shuffle to mix it up: 7 for riffle shuffles, thousands of times for overhand shuffles, and the time for smushing shuffles. Without mathematics, it seems almost impossible to reach those conclusions. Suppose you have 4 players. One way of dealing is to deal in a cycle. So to person 1, 2, 3, and 4, then 1, 2, 3, and 4. Another way of dealing is back-forth dealing. So you deal 1, 2, 3, 4, then 4, 3, 2, 1. As you might guess, but it's not at all obvious, the back-forth method is faster than normal cyclic dealing. One thing we talk a little bit about in the book that's speculative is using it to study traffic. If you imagine 2 lanes of cars sometimes interleave with each other, so you can think of them as shuffling around. Another application is to cryptography. Biology people study shuffling of genes. In terms of cards, the shuffle they're interested in amounts to taking a consecutive batch of cards in the middle and reversing their order. Sometimes we've had a hard time convincing people that this stuff is really interesting, but that's why we wrote the book. We want to share with other people that shuffling is related to lots of different parts of mathematics and other fields as well.